Lesson 1-9 is Understand Scientific Notation. Scientific notation is a way to write very large or very small numbers. We dealt with something very similar in the previous lesson, but we just estimated these very large or very small numbers. But scientific notation we can use to be exact when dealing with very large or very small numbers. There are two factors. You'll notice that the first factor can include a decimal value, but it's multiplied by a power of 10. The first factor is a number that's greater than or equal to 1 and less than 10. It will have one digit in front of the decimal. The second factor is a power of 10. And remember, these are called factors because their two numbers are being multiplied. This times right here tells us that we're dealing with factors. Example 1, we're going to write 8.273 times 10 to the 9th in standard form. I do want you to remember that this is the same thing as saying 8.273 times a 1 followed by 9 zeros. So that would be times 1 billion. We don't have to write that out that way every single time, but it's just helpful to recognize that we're dealing with a very large number. Now what we can do is we can take the decimal value we're given and give a lot of space around it, and we can count our decimal places. We know that this is going to become a large number, so which direction would we want our decimal to move to make this larger? If we go to the right, it starts getting larger. If I go one place right, I've got 82. 2 places right is 827. 3 places right is 8,273. And I can keep on going, except I don't have any more digits. So I'm going to add some zeros. And I want to get a total of 9 decimal places over. I've already gone 3, so I'll need to go 6 more. 1, 2, 3, 4, 5, 6. And I'll check that. I've gone 1, 2, 3 places, 4, 5, 6, 7, 8, 9. And so this number is now in standard form. I'm just going to polish it up and just write it more neatly. I always separate every 3 digits by a comma. So if I start from the right side, I'll go 3 digits and then place a comma. And so I get this number 8,273,000,000, and it's in standard form, the standard way we write numbers. Just one quick thing to note, had this have been a power of 10 to a negative exponent, like 10 to the negative 9th power, then we would have counted 9 decimal places again, but we would have gone to the left, and we would have wound up with a number that was 0.0000 something. Example 2, write 0.0000312 in scientific notation. So it's starting in standard form, and I'm going to rewrite it here where I have some space to count my decimal places, and I want to make it scientific notation. So let's just start with picking out our first digit that's not a 0 from the left, and that would be this 3. And so I could go ahead and write 3 decimal and everything after it, 3.12, and that's my first factor, times some power of 10. I've got to think of what that exponent is. So in thinking of the exponent, we're going to go ahead and count how many decimal places it moved. From the decimal, 1, 2, 3, 4, 5 places to get behind the 3. So we know that we're going to use the number 5 in the exponent, and then we just have to think of the sign. Is this a very large or a very small number? Well, it is 0.0000 something. So it's actually a very small number. Anything that's less than 1 is considered to be a very small number. So we use a negative exponent. Okay, so it's your turn to try a couple problems. I want you to write each number in scientific notation. You can look back at your notes and you can pause this video, try these, and then come back and check your answer. For number 1, 72,400, we can first look at the first digit. That's not a 0, that's a 7. And we'll write a decimal behind it. And every number after 7 until it's all zeros, you can write that as the first factor. And we know it's times the power of 10. So I'm going to figure out how many places this decimal moved. It started here and we're going behind the 7. So I'm going to count 1, 2, 3, 4 places. And I do have to think about whether this is a large number, something greater than 1, or a small number, something less than 1. And 72,400 is greater than 1, so I keep the positive exponent and I'm finished. On our second problem, number 2, we have 0.000000625. So I find my first digit from the left that's not a 0, and that would be a 6. And I'm going to place a decimal behind it and write all the numbers behind it till I'm at all zeros. And in this case, it just ends there, 6.25. And I know I'm going to multiply by a power of 10. And so we're just going to count decimal places. We're wanting to move the decimal back here behind the 6. So we'll count 1, 2, 3, 4, 5, 6, 7. It moves 7 places. And last, I just need to check whether this should be a positive or negative exponent. 0.000 anything is going to be a number that's less than 1. So it's a small number. So I have a negative exponent. And I'm finished with that problem.